Welcome back. Welcome back on one of the section that it's giving learners more marks only if well interpreted. In this case, that's vertical projectiles. Let's look at the problem solving. This question is normally question number 3 in a normal paper 1 question paper. The recent question paper here that I have in front of me was just saying to the learners, remember there are 3 graphs that are examinable: your position time, velocity time, and acceleration time. Now this one was given position time. They say the position time graph for a ball thrown vertically downwards from the top of a 48 meter high building is shown below. The ball bounces off the ground reaching a maximum of height of 8 meters. Ignore the effect of air friction and the contact time with the ground. So the contact time with the ground is negligible. The graph is not drawn to scale. This is the graph. Now in a nutshell, remember before coming to 3.1, I can just say we've got 4 types of motion scenarios here. There will be this first scenario where now the ball might be dropped or projected vertically downwards. And then we can have this one where now the ball is projected upwards and gets caught at the same level. And then we have got this one where now the ball is projected either from here to here or from here to here. So the bottom line here is that VI and VF are not at the same level. And the last one, which is number 4, is a combination, the bouncing ball. In a nutshell, then you can combine here. Let's say I combine 1 and 1, it will be this. If I combine 1 and 2, then the ball is dropped and then hit the ground and come this way. If I combine 3 and 1, the ball is projected from this height, come down, and then this case. So you can combine. That's the bouncing ball. But remember, the examinable part on this one is that we have to have at least one bounce. One bounce. Can even in a simple term nutshell and say they can ask you how many bounces should be 1. So can have 2 bounces in this case. So fine. The question here used, you can see in this case, used the scenario here, number 1 and number 1. So that's the case, a combination of 1 and 1. Let's go to 3.1. They are saying to us, according to this one, explain what is meant by projectiles. Remember, there are only 2 definitions here: a projectile and what you call the free fall. Free fall. When you are dealing with this section, know that one of the definitions might come in the exam. A projectile normally we say is a motion of an object in motion. An object in motion, underline that. Then now, whereas free fall is the motion of an object. The last part is the same. This one will be in which or whereby only, the word only should be there, is a mark, only gravitational force acts on it. Gravitational force acts on it. So that is this one, and this one will be a motion of an object whereby, again, only gravitational force acts on it. I think it's a simple definition because there are keywords there that the mark acts on it. They mark the last part. That's the case. Now we talk about the motion and then only gravity acts on it, then that's the case. 3.2, according to this question paper, they say to us calculate the speed with which the ball, in this case, is thrown vertically downwards. In this case, calculate the initial velocity. Now we can look at the graph. According to that one, we always advise learners to say, please write the 5 quantities: VI, VF, A, delta T, and delta Y. Remember, all the equations of motion is having VI. Therefore, VI, the direction of VI will tell us whether our direction we choose upward as positive or downward as positive. So we always follow VI. Please listen, we always follow VI. Fine. Now, again, this one is thrown vertically downwards. Therefore, VI is downwards. Therefore, if VI is downwards, therefore downwards will be positive. That's it. Now, we don't know the VI, and we don't know this one, VF as well. But we know that if it's downwards, therefore A becomes positive 9.8. And then according to this one, time is given is 2,8. According to the graph, you can see it takes 2,8 to hit the ground. Delta Y is given on the graph as well, is 48. So we are given 3, because all equations of motions, they've got 4 quantities. For us to use any of them, we must have at least 3. We've got 1, 2, 3 given, then we need the 4th one. So you go for the formula that doesn't have VF, or with this 4. Then it will be the only formula there, that is delta Y equals to VI delta T plus half A delta T squared. Therefore, delta Y is 48. VI is the one I'm calculating, multiplied by 2.8, and then plus half of 9.8 multiplied by 2.8 squared. Therefore, from here I can solve VI. The VI now will be the same as 3.42 meters per second. That is how easy you can deal with this question. Always be careful in this one. So fine, we found the VI. Now can even find the velocity with which the ball hits the ground. Now the second question, they say to us, calculate the speed with which the ball hits the ground. Oh, anticipating. Now if we have got this, now I've got this one is 3.42. Now I can always use any formula with VF now, because I know the initial. Can use it in the next question, then to say, oh fine, now I go and use any formula with VF. The easiest is the first one, VF equals to VI plus, A delta T. Therefore, VF is the one I'm calculating. This is 3.42 plus 9.8 multiplied by 2.8. In this case, remember the options will be many. Okay, now the final answer must be 30.86 meters per second. That will be the final. Now, this is question 3.2.2. 3.2.2. Now let's go to 3.2.3. 3.2.3. So in this case, they go and use any formula that's got VF in it. Remember, there are 3 formulas that have got VF out of the 4. Now calculate the speed with which the ball bounces upwards from the ground. You can see now, after bouncing upward, it reached a height of 8 meters. Now remember, as I said, we follow VI. Let's look at VI, VF, and then we have got A, delta T, delta Y. Very important, we follow VI. What is the initial direction of VI? According to this one, VI is upwards. Therefore, we take upward as positive. A becomes negative 9.8, and VI I don't know. It's the one I'm calculating. I know from here to here the final velocity at the top will be 0. I need one more. Delta Y is given. Delta Y will be 8 meters per second. Now I've got 1, 2, 3. I need the 4th one. So I go over the formula without delta T. There's only one formula. That is VF squared equals to VI squared plus 2A delta y, or the formula with VI, A, VF, A, and delta y. Therefore, this is 0 squared equals to 3.42 squared plus 2 multiplied by negative 9.8 multiplied by delta y. Oh, sorry, multiplied by 8. What is calculated here? I'm calculating. Oh, sorry, this is not. This is a VI. It's not given. We are calculating the VI. So I'm fine. Therefore, VI, that is the speed with which the ball leaves the ground with. Then if we use a calculator, we must find that that speed will be 12.52 meters per second. Just make sure that you use your calculator. 0 squared equals to VI squared plus 2 multiplied by 9.8 multiplied by 8, negative 9.8. In this case, be careful, negative 9.8. Fine. That is the 3.2.3. The last question, which is 3.3, now it was about the graph. Remember, I always say learners must fail with dignity. You must know that a velocity time graph is a straight line. A position time graph, you can see it's a curve, and a acceleration time graph is a straight line as well. Therefore, if they say draw a velocity time graph for the entire motion of the ball, indicate the following on the graph. In this case, you can draw, and then remember the initial velocity is downwards. We take downward as positive. The graph will have two sides, the positive side and the negative side. Remember, the initial velocity, according to the first calculation, is 3.42. That's positive 3.42. 3.42 is positive. The final velocity that it hit the ground with is 30. Should be above here. Should be 30.86. 30.86. And then, and that now we start from here. It took how many seconds? 2.8. So we go up, 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 up. This is 30, and then the time here must be 2.8. Now it bounces off the ground. When it leaves the ground, it was moving now at 12. Should be negative 12.52. That is the case. This will be the case. Now it bounces off. The slope will be the same because acceleration is the same, isn't it? Now that is the end, because it's now end at the maximum height. And that's all that you will be needed to show in this case. This is the time in seconds, whereas this is the velocity in meters per second. So on this one, you see all the things I indicate the following: initial velocity of the ball, that's 3.42, we are fine. Velocity with which the ball hits the ground is 30.86, we are fine. And the time taken by the ball to hit the ground is 2.8, we have shown that one. And the last one is the velocity with which the ball bounces off the ground, that is negative 2.52, so we are done. That's all the marks here, 4 marks. Then we are done with this one. So, which is very important to say, when you are drawing a velocity time graph, know that is a straight line. So velocity time graph is a straight line. A position time graph, it's a curve. Remember, it follows the path. Don't forget that we have got 4 types of scenarios here in projectiles. That is, the ball is dropped. Initial velocity can be 0. When the initial velocity is not 0, means that the ball is thrown vertically downwards. The ball is thrown vertically up and catches here, means that if here is 10 meters per second, at this side it will be now negative 10 meters per second. So fine, if this one is 8 meters, following this, also when it passes here, it will be now moving at 8 meters per second. Obviously, the final, without calculating, you know, is bigger than 8. That is the case of this one. So I think you will find with this few enlightenment or green giving you green lights, then it will make you in maybe eligible to can solve other questions related to projectiles. Good luck. Thanks until we meet again. Okay, bye-bye.